Good evening to all stations on frequency. This is the Henderson Amateur Radio Club Sunday Night Tech Net. My name is Earl, WB6 AMT. I'll be tonight's host. We got a couple of fun things going on tonight. For those stations unfamiliar with the website that we use to follow along with our narrative, please go to WB6AMT.com. In the upper right-hand corner, click on HARC TechNet. Scroll down to today's date, June 6th, 2021. And we've got some fun things to talk about tonight, and then the main presentation is going to be on the 18650 lithium-ion battery. Some folks are starting to call it the king of the hill of batteries. I don't know if I would do that, but I do know it's in a lot of stuff, and we're going to cover an awful lot of that tonight. It's a common battery used in most of the power tools now. A lot of devices, not just tools. Equipment also, electronics, you name it, it probably is in there. At this time, I'm going to take call-ins, check-ins, and if you look at the picture that we have posted on the website, the first one, you'll see it's for a 10-megabyte computer system, and at the time, the sale price was $5,995 complete for a 10-megabyte computer system. So that's pretty funny. We've come a long way, certainly. When you check in, real quick, tell me if you remember what your first computer system was. Did you build it, buy it, find it, whatever? WB6AMT, call Net Control now.
This is K7GKW. My first computer was, at least one I bought, was a IBM PS1.
Okay, could you give me your call sign again a little bit slower? We are a bit hearing impaired here, so I need to get that down correctly.
I'm sorry, it was K7GKW. That's Kilo 7 Golf Kilo Whiskey.
Okay, thank you, K7GKW. Other station, call Net Control now.
W6MW.
And 7XO.
WB6MIE, first computer, Apple II Plus. I think I got my mother to pay $2,000 for it without a language card or an integer card. 8K of RAM.
Yeah, I had an Apple II also. Let's go ahead and get W6MW. Go ahead, Mark.
Good evening, Earl. We're coming to you through the W7SCS repeater, so you are linked in tonight. Mine was also an Apple II Plus, 16K of RAM, audio cassette interface, video adapter, so I took it down to 400 line, basically. It cost me close to $2,000. To NBC, I had an incredible continuous tour weekend, and I took a lot of that money, and I went to the computer store and updated it to 48K with two 5-inch floppy disk drives, and that cost me another $3,000. And I think I gave the whole thing away to somebody for $150.
Okay, thank you, Mark. We are getting a bit of the gurgling on the network right now. N7XO. Good evening, Don. What was your first computer?
I can't quite. I remember one of them. One of them that I can remember was a VIC-20. I believe that had 20K. I'm not sure. I can't remember how much memory, but it wasn't much. Was my first, and then later Commodore 64. Over.
Oh, very good. Any other stations? Please call Net Control now.
KJ7OEN.
KF7JAF. KJ7OEN. Good evening, John. Go ahead.
Thank you, Earl. How are you tonight?
We are doing well. What was your first computer? We currently have a picture up on the website out of an ad that I scanned out of a Popular Electronics back in 1980-something, showing a 10-megabyte computer system for $6,000, which included, I might note here, a 28-amp internal power supply. Go ahead.
Well, I wasn't as fortunate to have something like that. My first computer was a Timex Sinclair, which I ran on a little portable TV with a 6-inch screen and a cassette recorder.
Excellent. I remember those. Okay, KF7JAF. Good evening, Dave. What was your first computer?
Good evening, Earl the Net, KF7JAF. In 1979, I bought the TRS-80 Model 1 after much trepidation and reading magazines and catalogs and trying to figure out what to buy. I decided that was probably the best option. Whether or not that's true, I still don't know. But anyway, I had the cassette recorder and everything was built into the keyboard, and you saved your programs on this little tape that you stuck in the cassette recorder. Later on, I spent a bunch of money and bought the expansion module with the full 48K of RAM and a couple of floppy disk drives. And I had that thing for years and years, and it wasn't until 95 that I got a 486 with Windows 3.1 on it. But that's another story. So anyway, back to that control, KF7JF.
Very interesting, Dave. Okay, the next station, all I got was, I believe, AKI. Would you please come back with your call sign if that's even close?
KJ7YKI, Mike.
KJ7YKI. Good evening. What was your computer?
My first computer was an RE800 console, but it was an actual PC that you had to put a DOS cartridge in order to program. Had the 5 1/4 floppy and the old place in your phone and dial modem.
Very good. Just a point of reference here, or information. It sounds like you're on a portable moving around. If you could possibly hold your radio still when you are transmitting, it'll produce a little bit better signal. You won't drop out of the repeater quite as much. Any other stations? Call that control now.
Whiskey Victor 3 WJ3V, Jason, in north central Las Vegas.
Okay, I got
WPS.
3 stations there. Let's go with Jason and WJ3EP standby, and then the third station standby again. Go ahead, Jason.
All right, thank you there, Earl. WB6AMT WV3V. Good evening, and to everybody else on the tech deck. First computer was a Commodore VIC-20 and a cassette tape as the hard drive. A friend of mine had a TRS-80. His dad was into programming at the time in a machine shop, so I got a chance to see that. But I started with a Commodore VIC-20, then moved up to a Commodore 64, and then took basic programming in high school, of all things. I remember sitting laboriously hours on end with a magazine called Byte Magazine, I think it was, and they would have pages and pages of code, and I would sit there and laboriously type that in only to find syntax error after syntax error after syntax error. More than most likely it was a misplaced colon or semicolon. So, all good stuff. WV3V.
Oh, I sure remember those days. Okay, thank you, Jason. Jay, WJ3EP, go ahead.
Yes, good evening, Earl. Good evening, everybody. My first computer was also the Timex Sinclair ZX80. It had all of 2K of RAM, and I remember having to save and scrape my money together to buy the 16K upgrade. And then eventually I got a cassette tape to be able to save programs to, and then from there I upgraded to the IBM PC when that was released. WJ3EP, back to Net Control.
Oh, very good. The third station in the double, or in the pile up there a moment ago. Come back with your call sign again, please. Okay, any other stations wanting to check in, please call Net Control now.
KJ7SEB, John. KJ7 WPS.
Kilo Bravo 7 Hotel Tango Alpha.
KA9 MSD.
Okay, well let's grab these last 4 stations. We'll start at the bottom. KA9MSD. Can I get your name also, please?
Yes, Earl, and good evening in the net. It's Rich, and I guess the topic on computers, my first computer in the early 1980s, and I hate to break up the quorum here on different boxes, but I actually had a Texas Instrument 99-4A.
Well, thank you, Rich. There's definitely what's the word I'm looking for? A wide array of different types of computers. I haven't gone into my first computer yet, but we'll catch that after everybody gets checked in. KB7HTA, good evening, Tommy. How are you?
Good evening, Earl. This is KB7HTA. My first computer, I built it, and it was in 1973. It was a TV typewriter. A year later, I added an 8008 processor to it with a fantastic 256 bytes of memory.
Oh, outstanding. So you had to work for it. Okay, KJ6WCS. Good evening, Steve.
Hey, Earl, this is KJ7WPS Tom. I think maybe misheard.
Okay, well, I can blame it on my hearing, but it was close. KJ7WPS. Go ahead.
Good evening. My first computer was in the household was a Commodore 64 with the cassette, and we actually had the real monitor for it. I also have moved on. We had the Trash 80 at school, the various Apple products and all that. But yeah, the Commodore 64 is the first one in the house. And incidentally, I have a TRS-80 pocket computer on display here at home, and the Commodore 64.
Well, that's great. You've got your own museum going there. Okay, next station, it was a difficult copy. It could have been a little bit of noise, but I think I've got FEB. If that's even close to that station, please come back.
Kilo Juliet 7, Sierra Echo Bravo, John. And my first computer was, I think, a 1997 Compact from Costco. Back to net.
Okay, very good. Thank you. KJ7SEB. Any other stations? Call net control now. WB6AMT.
This is KD7ZHA.
KJ7RNB.
Okay, I believe I got a AHA. That station, come back, please. Okay, Steve. KJ7RNB, go ahead.
Good evening, Earl and the net. My first computer, I don't remember the brand, but I know that the operating system was CPM operating system. I bought it from a dealer who shortly thereafter went out of business, so I didn't know anything about it, had to learn it all on my own. And from that point forward, I said, I'll never be dependent on anybody else for support. Back to you, Earl, KJ7RNB.
Well, that's pretty good. My first computer that I built was a CPM machine. My first computer actually was an Apple II, and then the 2 Plus, and then the 2E. And with my 2, I managed to go to L.A. That was the big thrill at the time, was to go to Los Angeles and buy additional interface cards. Some of them you had to build because they were blank PC boards. But I managed to get a 4 floppy disk controller card. And then I went over to another surplus store and bought 4 10H floppy drives and brought them home. And I could finally run DBase before it was DBase 2, which was what my interest was at the time. So, now we've all got some great stories, I'm sure. Any other stations want you to check in? Call net control now.
This is KD7ZHA.
Okay, you're just a little bit noisy. Did I get that correct as ZHA, Zebra Hotel Alpha?
No, it's Kilo Delta 7, Zulu Hotel Alpha.
Very good, sir. What's your name and what was your first computer?
The name is Alan. Thank you for the net. Hi, everyone. But my first computer was a Commodore 64 until I could purchase 386 and leave the 64 and all the programming and problems behind.
How great is that? Okay, one more call for call signs. Otherwise, we are going to go ahead and start our discussion this evening on the 18650 lithium-ion battery. Call net control now. Okay, for everyone that's on the website, you can see that there's another picture directly underneath our $6,000 computer ad that we had posted there. What you're looking at is Motorola's first mobile phone. What you're seeing is the transmitter, the receiver. Receiver had the controller built in it, and the power supply. And from what you can see here, it's lucky that it wasn't any bigger, or there wouldn't be a spare tire, I don't think. I hate to see myself, but I have actually had to stick my hands in some of these. Not very many. Actually, they were being removed out of service from vehicles. But still, an absolutely incredible piece of equipment that was built that the quality of the connectors alone just, impressed the hell out of me at the time. Anyway, we have anybody with any comments about old two-way radios? Call net control now.
Yeah, that's a 30D transceiver. You got yourself I think that's the receiver on the left-hand side there, and the transmitter on the right-hand side. The box on the right is a 106A selector. That's the box that had the little electromechanical solenoid thing in it that would decode the number when it was called using 600 to 1500 transitional signaling. It was an amazing piece of mechanical engineering, and it had to be kept clean, so it was under a little glass lid. The actual selector mechanics were. I've got one around here, but I don't know where. WV6MIE.
Well, thank you, Tony. Appreciate getting that. Okay, we're going to continue, and tonight's discussion, as I said earlier, was the 18650. This lithium-ion battery is pretty much become a workhorse. We're finding it in so many different things. A lot of projects are being designed around, 3.7 and 7.4 volt battery packs. You can get them really cheap, almost like little AA holders, except they're for two of the 18650s. I got to say that everything here is for informational purposes only, because I'm going to kind of step out of the box a little bit farther down and show some very unorthodox experimentation on some batteries. And I don't want anybody to try that. I'm just showing it for informational purposes only. Keep in mind that not using a battery correctly or not following proper charging specifications can result in burns, fires, cells rupturing, exploding, damage to your equipment, all that bad stuff. So, when dealing with and handling batteries, always wear eye protection, and if you're going to do any experimenting, just do so very carefully and not haphazardly. One of the things that was predominant about this battery was that you couldn't damage it because it would literally self-destruct, catch fire, explode, burn, catch people's pants on fire because the battery in the phone went sideways. So it's a pretty wild little device. Okay, I am not an expert on lithium-ion battery chemistry by any means. I do like to attempt to know about as much as I can when I'm working with electronic components, including batteries, so what I can and can't do. A lot of the information for tonight is, good old-fashioned research that you can find by digging, as well as some personal experimentation that I have done in the past. And, of course, there's a lot of stuff online that just goes on and on. Some of the things that originally were concerned about the lithium ions were they getting safe? Were they safe at after all of the problems, and we saw toys catching fire and telephones catching fire. But they've come a long way at this point. Is there any comments or questions? I'm going to do this a lot of times tonight so that people can get their comments and comments and questions in. Call net control now. Oh, come on, guys. I know you guys got to have some questions. Well, let's see what happens a little farther down the road here. There's basically two different types of lithium batteries, lithium ion. If I leave off the ion, I'm not doing it intentionally, but you know what I'm talking about. These cells are called protected and non-protected cells. Non-protected cells are strictly batteries that do not have a BMS or a battery management system board built into the battery. A lot of them do, a lot of them don't. Protected cells have the BMS board normally underneath the shrink wrap. If it's like a two-cell package producing 7.4 volts, it'll be a little skinny board in between the batteries. But they're normally underneath the shrink wrap. And these prevent the batteries from being overcharged, from overcurrent demand, they're protecting all the aspects of the battery. Number one picture shows some of the different types. You can see all the connections on a few of them that go to the separate individual cells. The BMS board is instrumental in what's called cell balancing, and that is when you look at picture number 2, you see 4 batteries there. Every cell is actually being dealt with as an individual battery cell. That way it can maintain and keep the cells as a whole from not being overcharged, protected against high current or short circuiting, things of this nature. Any comments or questions? Call net control.
KJ7 WPS comments?
Go ahead. KJ7 WPS.
So I have not personally dealt with this, but I've heard fairly often that if some of these BMS boards lose power, as in if a battery goes too dead or is disconnected when somebody's trying to rebuild one, they'll just stop working. So either, I don't know why, I think it's a protective mechanism that once they lose power, they shut down and are dead.
Well, I'm going to go into dead cells here in just a little bit, particularly a device called a SID, which is a current interrupter device. So stay tuned and all that. Let's see here. Yeah, when is an 18650 charged? Well, the normal voltage is 3.6 to 3.7 volts. A charged 18650 will go to 4.2 volts, and a cell is considered exhausted or discharged at 3.3 volts or close to that. I'm currently using a bunch of them in the hidden transmitter that I built. I have 16 of them in a combination series parallel circuit. The dual transmitter the T-Hunt transmitter has 2 radios in it, one for VHF and one for UHF. With those batteries, I can operate it for close to 6 hours continuously, and then I think it rolls off pretty quick at that point. Picture number 3, if you've bought anything off the internet, then you know that there is so much Chinese counterfeit stuff out there, it's kind of hard to distinguish between, well, even when I've ordered some stuff for my Motorola portable, like a speaker mic. I actually got one in, and I thought it was an OEM, but all the markings, everything about it, looked like it came straight out of Schaumburg, or wherever the Motorola portable accessories were being made from. So, detecting fake batteries from real batteries can be an issue. There's only 4 quality 18650 manufacturers making the batteries, 18650s. They are Sony, Samsung, Sanyo, and LG. In the picture number 3 here, you can see the pictures on the left, which are the real ones. They're stamped, which, anything could be stamped. But the secret is the color of the cell. The fake ones on the right-hand side are like a collection of clown wigs. They're all different colors, all different shapes, styles. Oftentimes, the counterfeiting is so bad, one way of detecting whether a battery is original or not is to weigh the battery. The 3400 milliamp cells typically run a little bit heavier than 45 grams. Fake typically under 40 grams, and I've had some that I've measured that were actually, less than 20 grams. I think it was like 18 point something. These obviously have a very, very limited capacity, under 500 milliamps, so they don't last worth a damn. If you buy any batteries from Walmart, most likely they are going to be counterfeit because they don't hold a charge and they cannot handle the current demand of, say, 2,200 milliamps. Now, there is one brand that is always a fake, and that is the Ultrafire brand. And I've seen those Ultrafires sold in so many different websites and in stores. So they're marketing them all over the place. Some of them are marked even higher than 400 or 4,000 milliamp, which is, I don't think that's currently possible at this time. Any comments or questions at this point?
AF7JAF.
Go ahead, Dave.
So, Earl, are these like regular AA size, or are they like a different weird size that's like non-standard?
Well, the 18650 is, I would say, about a half inch longer than a AA, and probably half again as thick. They're a little bit bigger battery. They're all the same size as far as an 18650, but they, as far as a conventional AA or AAA or anything like that, they're completely different from that, Dave.
So they were used in cell phones, and what else might they be used in?
Well, the 18650 is utilized in probably almost every manufacturer of cordless drills, lights, some work lights, like the Makitas, the Ryobis. The battery pack that they have are normally made up of 18650s, a number of them in the pack, depending on how big the battery pack is.
So my Harbor Freight drill probably has a bunch of these in the battery pack.
Oh, yeah. They're Bauer and Hercules tools that Harbor Freight markets. I've opened up one of the Bauer packs because I've got several of their tools. And they can say that's what they contain are 18650s. I don't know if the car manufacturers are going to, thousands of these things or what. I'm sure they're going with something a little bit more conducive with the demands of the car. But anything that's using rechargeable or, anything that's cordless, rechargeable, other than a small cell phone, most likely is using 18650s in there.
An APSD.
Go ahead, the last station.
Yeah, an APSD. Just a quick comment. The Tesla battery packs are made up of like 4,800, if I remember right, 4,800 of these 18650s. And please check me in late check-in. An APSD.
Yeah, I had heard that at one point, and I just found it to be so incredible. Okay, let's move along here. How to tell the battery current size by the color. Most Samsung cells are kind of a cyan color. Note that the other smaller companies use this color, but only Samsung has Samsung actually written on it. So that'll give you a clue. You can see a couple in the picture there. This particular ones are showing the 2,000 milliamp cell. You can tell by the last three digits there, the 200. That's how you can tell it's a 2,000 milliamp cell. It'll have the same color, but you'll see 22 or 220 and 240 for the 2,200 milliamp and the 2,400 milliamp battery. The best thing, the best way to identify them is by looking at the line number, again, by that number on the end, and that's for the Samsung battery. Okay, moving right along to Sanyo. Most Sanyo cells are all red. The new fake red that's been, infested with a little bit of blue, changing the color. They're hard to identify. But the real red cell actually consists of a three-color red, green, blue of Q55, 0, and 0. There's no blue in there. So the 2,000 milliamp original ones were indeed read by all standards. The little cap at the top was white. If it's a pure red one, like in the picture there, then they're 2,000 milliamp capacity. Actually, I think that's a typo. I'm going to have to check into that. Yeah, a typo. Because I believe the all red should be to 2,200 milliamp capacity. Anyway, it's hard to see in the pictures, but just underneath that little rib circling the button is where you might see a different color, and that's the cap that's underneath it. It should be red. The 2,600 milliamp ones have a cyan cap, but those also have been baked a lot. So you want to keep an eye out for that. And Gordon here says that the Sanyo cells use the 1,500 ones, 1,500 milliamp ones in power tools, which I have found that to be true. Tearing some battery packs apart, and they have a pink or a light blue cap underneath, which is a ring underneath that up by the button. Now, the Sonys are all standard green. They're all the different sizes, they're all green. The way you do read it is with the G number. It's very difficult to read it in this picture, but there's a G number that's used as the capacity identifier for the Sony 18650s. And last but not least, LG. The thing about LG is that they can be identified by color, and they've got lots of them. The 2,000 milliamp cells are kind of a pale orange, as you can see there, and they are identified with an LG and then a number. The 2,200 milliamps are gray. It's one of their most popular ones. The 2,600 milliamp is kind of an orange, a little bit darker orange. The 3,100 milliamps are purple. And each manufacturer has a trick. For Samsung, you have to check the tag at the end of the line. For Sanyo, it's the color cap. For Sony, it's the G-spot. And for LG, just the cell color itself to determine the current capacity for each individual cell. Any comments or questions? Call that control now. Okay, there's the next section here, how to solder 18650 batteries together. Now, in theory, you're not supposed to do that. It's not good to solder regular batteries because the chemistry is directly on the other side of the contact. That's not necessarily the case with 18650 lithiums, and I'll go into that. But the way to solder it, my recommendation, this is how I've done it, is use a good high current or high temperature soldering iron with a chisel or conical tip, at least an eighth of an inch wide. I use 6236 silver solders, if I don't have that, then at least a really good rosin core like a Kester or Urson 6040. I use a little sandpaper or a real fine file and scuff the surface where it's going to be soldered. About an eighth of an inch is plenty. Tin the wire, while holding the wire down on the scuffed area, apply just a small amount of solder with the iron against it, and it will flow instantly because normally it's a nice clean surface. Remove the iron and without moving the wire. It will only take about a quarter of a second. It doesn't take long at all to do this. Now, the reason it doesn't affect it because of the chemistry not being against the other side of the metal is twofold. One, a lot of the batteries that do have the BMS circuit, it's normally in the bottom of the battery. The second thing, the top connector, or the button, most likely has a CID, a current interrupter device. And so you're not really, the chemistry isn't against that either. So heating it up for a moment isn't going to create any problems. Any comments or questions before we go on to how to fix a non-rechargeable battery? When an 18650 battery always shows that it's not charging or charged, normally giving you a green light on your charger, but only has a voltage of about 2 volts, that causes the charger to get real stupid and then misread the battery, and it can actually overcharge, cause overheating, but normally it just doesn't charge it. With a properly charged good battery, you can measure 4.2 volts or a little under that. You can sometimes jumpstart a cell by connecting the good cell, same type and size, with a pair of clip leads to your sick battery for no more than about 10, 15, 20 seconds. Positive to positive, negative to negative. And while you're doing this, feeling the batteries to see if either one of them is starting to overheat. The battery being jump charged, it may be a little warm, but after about 20 seconds or so, pull it off and take a measurement. If the voltage is over 3 volts, then you've just managed to give it a little cardiac arrest, jump start there. And at that time, put it in the charger and cycle it through, and more times than not, it comes back to life. When in doubt, if a battery's out of warranty, just to be on the safe side, throw it in the trash can. Now, what is a SID? SID is a current interrupting device that is built into the top of 18650 batteries. It's interesting that, and you can see in the picture there, you see the little slots in the tab. That is actually what allows an external tool to reset the current interrupter. Now, if you look at the drawing, and it's my drawing, so just bear with the, I'm not an artist by any means. The battery cell itself is separated from the top middle contact by a little round button that's caved in, and it'll pop. And when there's overcurrent being drawn, that contact pops in the up direction, as you can see there, and does not make contact with the battery anymore. And if you take a thin tool, a small jeweler screwdriver, you can actually go into those little slotted holes in the top and push that down, and then you'll hear it go pop, and it now is in the downward position and is making contact. And when you measure your battery, you'll see that you now have voltage out of the battery again. That normally occurs when there's a short circuit on the battery to protect it. Any comments or questions at this point? Well, if you ever measure a 18650 battery and it has 0 volts, that's typically a battery that the SID has been tripped, the current interrupter device. So taking a small jeweler screwdriver, maybe sticking it through the little slot there and kind of wedge it down. If you do that and you hear the pop or you feel the pop, you're probably good to go. If not, well, at least you tried. Anytime you bring back a battery to life like that, I had that happen with a relatively new one. It had lots of current. It took a charge well, and it tripped because of a shorted power supply cable. I tried charging it before I found out about the SID. Once I found out about it, reset it, the battery came back to life. So there are some little tricks that you can do like this that will save you money and time down the road. At this time, are there any stations that would like to check in? Call Net Control now. Or if you have any comments or questions about, anything about the battery right now, call Net Control. Like most batteries, when you measure them, even a dead battery will have some, I've seen batteries that have been sitting in a drawer for a year or more, and you put a meter on it, and you'll see 0.6 of a volt, or, 0.2. You put them on a charger, and they come back to life. But to have 0 volts indicates to me that the SID has been tripped. I also tore one apart just to see, and it's constructed just like that little drawing there. That's actually how I was able to make that little drawing there by seeing it. Okay, moving right along. This is a 4-cell lithium-ion charger. Not real expensive. I think it was around $29. It's a great charger. It'll exercise them. You can charge as many as you want, up to 4. Next picture there is a little dashboard of it. Milliamps, particular voltage rating. There's also a document here that you can click on. about 18650 cells. If that link does not work, I would appreciate if someone would let me know, because I had finished this thing kind of quickly this afternoon and didn't get a chance to double check that, but it should. Yeah, seeing as how these batteries are being used in so many different applications where high current and high voltage is being is the demand. I had read that there was over 4,000 of them in an electric car, but I didn't remember the article, so I didn't mention it. Thank you, Nate, for bringing that up. If you experiment with any of these batteries, just be very careful, because they are capable, even though they have small wires coming out of the battery packs, they are capable of giving you amps of current. So be careful and just use them safely. I actually charged the battery packs in the T-Hunt transmitter with one of my adjustable power supply boards that I've set for 8.4 volts. So it takes 3.7 times 2, and it never overcharges them, so I don't have to worry about them overheating. So that is about it for tonight. That's about all I've got. Does anybody got any questions or comments about using or anything to do with the 18650 batteries? Call Net Control now. Well, I hope I didn't put everybody to sleep.
KJ6 WCS question.
KJ6WCS. Hello, Steve. Go ahead.
I was going to throw this in earlier, but you were on the roll. But can you explain a little why these batteries are so volatile?
Well, not being real familiar with the chemistry, the lithium-ion chemistry of the batteries, because of the number of plates, and the plates on the lithiums are so much thinner than the plates on a conventional battery. I'm pretty sure that it's just the sheer number of elements involved to create the current, and that's what really does it. I think everybody saw on their phone a few years back some idiots taking a nail and a hammer and driving a nail into a lithium battery out of a cell phone, and it explodes and catches on fire. I don't know how many layers the battery has, but just to have that kind of capacity is just amazing to me. So I wish I could answer that better, Steve.
Oh, no, that explained it a lot. Maybe I'll look it up a little more and go a little more in depth. I'll let you know. But I appreciate the info, Earl. Really do.
Yeah, click on that link there, the blue link. It says 18650 cells. That should take you to a 9-page document, and that'll probably have quite a bit of information for you. Any other stations with comments or questions? Call Net Control.
The amount of potential energy in the cell and the chemical reaction that can run away with the heat, plus lithium metal burns.
Yeah, I've heard that it also takes advantage of the oxygen content now that the chemicals are being exposed to. So that makes a lot of sense.
And ABSD.
Yeah, go ahead, Nate.
So I got a question. Earlier today, I was using my, battery-powered Ryobi Sawzall, and, did my job. When I was cutting, it only took, a few minutes, or like a minute. And, the battery pack got a little warm, which is typical on those, but I took it off and, waited. So I usually check it, after a few minutes to let it cool down before I recharge it. And surprisingly, it got hotter, and it continued to get hotter, and it was really starting to freak me out. I was really worried about a fire. Curious if you've ever seen that, or I ended up putting it on a big chunk of metal that pulled the heat down. But and it did eventually cool off. But it really surprised me that after I took it off the drill, off the Sawzall, it continued to get hotter and hotter.
Hey Nate, by any chance, when it was getting hot like that, did you put a meter on it and see if the voltage was changing?
Negative. I just had it, sitting on my workbench when, and typically, I'll put it up to my cheek to check the temperature, and it was like, holy cow, it continued to get hot. So, and I have not tried to recharge it at all since then, and I did not take it all the way. It wasn't like it was dead. it still had probably, at least 50% left of its usage.
Most electronics has temperature differentials that separate where it is in operation, where it's still operating normally, and then where it's starting to go into a restricted, lower output or some sort of a problem condition. The problem with us humans is what feels hot to us may be another 40 or 50 degrees away from its potential, its danger level for the temperature. I found this to be true with the Raspberry Pis. I was told that a lot of them are overheating and this type of thing. And so by placing thermocouples on them and measuring them, and then finding out later on when I'm touching them, oh yeah, they are pretty hot. But the actual measurement is like 145 degrees, and the operation, is for like the processor. I think is 170 degrees. And on the Raspberry Pi, the LAN chip, the top temperature is 160 degrees. It's 10 degrees cooler. So these devices can be really hot to the touch and still just be cruising along as far as from an electronic component standpoint. Thanks a lot for your input on that, Nate. Appreciate that. Anyone else with any comments or questions? Call Net Control.
Comment for Nate, W7MAG.
Go ahead, Paul.
Thank you, Earl. Good evening. One of the things that I've noticed with the 18650s in like your tools is a lot of times it will still be wicking heat out of the cells themselves into the surrounding plastics and stuff. And many times I have an electric mower that I use. It's a Ryobi, and the actual battery will continue to get hotter and hotter, probably for a good 15-20 minutes. And it can be alarming. So I usually end up throwing them in the fridge for about 10 minutes and then taking them out. But I'm sure it's not good for the milk, but it makes me have peace of mind. Anyway, that was all I had. That's it. Back to you, Earl.
I have been known to throw my multimeters in the refrigerator or the freezer myself. One of the things about LCD liquid crystal displays years ago was that the sun, if you were outside working on a car or installing a radio and the sun was shining on it, all of a sudden I look over at my meter and my display is solid black. And of course that freaked me out, and it was very hot. I took it in the house, put it in the refrigerator, and after a while went in, checked it, everything back to normal. So the refrigerator is a service tool in a form.
It's also
okay,
nice
well, if no one else has any
device.
comments or questions, then we'll go ahead and wrap things up for the night. One more call, WB6AMT. Well, gentlemen, thank you for joining us tonight. This is a fun one to talk about. I'm going to try and come up with a picture every week now. I've got a pretty good collection of old antique stuff, Motorola radios, old communications equipment, and we'll see if we can't come up with something, at least one picture every week for a little bit of a discussion before we get into the meat and potatoes for the net. Everyone have a great week. Stay cool. It's uncomfortably hot out here even right now. And of course, stay safe. It's WB6AMT, the Henderson Amateur Radio Club's radio repeater network, being returned back to normal operation. 73.
That's normal, such as it is.
This has been a production for the HARC Amateur Radio Repeater System. Post-production by W3. Copyright 2021. All rights reserved.